Today's lesson is going to review some of the concepts that we've learned about sound. Sound is caused by vibrations. If there are no vibrations, then there is no sound. We've also talked about properties. Each object has different properties. It can be how they feel, how they look, how they smell, how they taste, or how the object sounds. Some of the different sound properties that we can observe are high pitch versus low pitch, loud versus soft, or even the type of sound that is made, like a ringing or tinging noise versus a clap or a thud. When objects have similar properties, or when sounds have similar properties, then we have a difficult time using sound discrimination. Sound discrimination is our ability to tell two sounds apart. Sometimes we are easily able to use sound discrimination, and sometimes we are not. The video that I am about to show you will show you the difficulty of using sound discrimination and some of the confusions we can have with this concept. Remember, when objects are using similar materials, for example, we looked at metal objects, we have a tougher time using sound discrimination because all of the objects can make the same sound, versus, like, for example, a washer or a coin. When objects are made of different materials, like wood versus plastic, for example, the sounds that those objects make are very different, so then we're easily able to use sound discrimination. Let's check out this video for more details.
Hi kids, I'm Captain Molecule, and this is my think tank.
Hey, Siam, where are you? Is everything all right? What happened?
Wow, did you hear that?
Of course I heard it. Did anybody get hurt?
I don't think so.
Seriously, Siam, what happened? Isn't that the ambulance or the police?
I don't think so.
Can't you hear that first glass shattering now siren? Something must be terribly wrong. Was there an accident? What can possibly be funny at a time like this? Siam, do you have any idea what's going on?
Relax, Mrs. A. What you're hearing is just a new sound effects tape that I bought to teach sound discrimination.
Sound discrimination? Oh, that's a pretty cool idea, Siam. I really thought something was wrong because those sounds reminded me of an emergency. Then someone was laughing, and that really didn't make sense because usually that means something funny happened. I was using the clues from the sounds that I heard to try and figure out what was happening.
Sound discrimination. The ability to recognize differences between sounds.
Hey, I gotta go, Siam. Someone's at the door.
Cool sound effects tape, isn't it?
We use sound discrimination in our everyday lives to tell when certain events are happening, like if it's an emergency, or if somebody needs help, or even when it's time to have fun and enjoy something. To end our lesson today, we have a short reading to do in respect to the lessons we've learned about sound. The following reading addresses the concept of sound source and sound receiver. A sound source is anything that makes sound. So anything that can produce vibrations in order to cause a sound to occur is considered a sound source. A sound receiver, on the other hand, is anything that takes in the sound and responds to it. For example, humans have ears as sound receivers. Microphones, voice recorders, those are also examples of sound receivers. The device that you're using right now could be an iPad, for example, which would be a sound source because it can make sound, and a receiver because it can record sound. We'll do some more work with sound source and receiver this week. But in the meantime, think about sound source and receiver as you listen to the following reading. Animal babble. Grunt, squawk, buzz, chirp, croak, roar. Animals use their bodies to make all sorts of sound. And like the sounds made by people, animal sounds communicate all kinds of information. Animals make sounds to signal danger. They make noise to signal their mates. Some animals make sounds to tell other animals where to find food. You know that every sound has a source. The source produces vibrations. But for those vibrations to be heard as sound, they have to reach a receiver. Humans use their ears as receivers. Many animals, such as dogs, cats, and horses, have ears that work the same way human ears do. Humans cannot move their ears, so sometimes turn their heads to hear sounds better. Animals such as dogs, cats, and horses can turn their ears in the direction of sounds without moving their heads. Insect yakety yak. Not all creatures use their mouths to talk, and some don't have ears for receivers. In the animal world, insects have some of the more interesting ways of communicating. They use different body parts as their sound sources and receivers. The male cicada talks with his stomach. The stomach has stiff plates on it called tymbals. Cicadas push their tymbals in and out to make noise. It's like making noise by bending a cookie sheet in and out. Crickets and grasshoppers are famous for loud chirping sounds. Crickets talk to each other by rubbing their wings together. Grasshoppers make their chirps by rubbing a leg against a wing. Crickets and grasshoppers also have special sound receivers. In addition to ears, they sometimes use their antennae, or feelers, to hear. Other insects use their antennae as receivers too. Bees make buzzing sounds by vibrating their wings. But bees don't hear the buzzing sounds with their ears because they don't have any. Bees sense vibrations through their bodies. Tattletale. Snakes don't have voices. A rattlesnake talks with its tail. The end of its tail looks like a rattle. It is made of pieces of thick, dry material that is something like your fingernails. When the rattlesnake senses danger, it shakes its tail, making a rattling sound. Snakes do not have ears either. They hear by feeling vibrations through the ground. The vibrations are sensed through the snake's bones. How do fish hear? Like snakes and some other animals, fish do not have ears. They sense vibrations mainly through a tube called the lateral line. The lateral line runs along each side of the fish's body just under the skin. Vibrations pass through the fish's skin and shake tiny lumps of jelly in the tube. The jiggling jelly touches nerves, and the nerves send messages to the brain. Questions to explore. What kind of information do animal sounds communicate? Can you name 3 unusual animal sound sources? What are they? Can you describe some animal sound receivers? What are they? These are some of the questions that you can think about for us to discuss next time we meet for science. We will continue to investigate vibrations and will learn more about sound source and receiver.